evening to you. So, today's topic is from the chapter of rotation. Now, in the chapter of rotation, at some point, what you find is that a body has both rotation and translation. Now, imagining this type of motion is very difficult. How do you articulate the velocity of a point given the velocity of another point? So the velocity of one point on the rigid body is known, and you have to describe the motion of the other point on the rigid body. And so when you look into these questions, the key characteristic of these questions is that they have translatory motion, which is they're moving straight, and they also have rotational motion. But the way to visualize the rotational motion is with the help of a concept which is close to relative motion. So what I'm going to show you now is the basics, the concept of how do you find the velocity of a point on a rigid body, which is having both rotation and translation, when the velocity of one point is known on the rigid body. So you have 2 points in the question, and one point's velocity is understood. We have to find the velocity of the other point on the rigid body. The body is having both translatory motion and rotational motion. So how will you find the velocity of the other point, and how do you describe this motion is what we will see in my upcoming video. So I'll just start writing on my teaching board, and you can follow. It's a short video, very crisp video, very useful for people preparing for NEET and JEE examination. Okay, the combined translatory and rotational motion. Thank you very much. Keep working hard. Please don't get discouraged if you score less in some examination. This, what we're trying to do is make progress. And everybody has their own pace of learning. It doesn't matter whether you're scoring more or less. Progress is very important, okay? If you're not making progress, that should be the worry. The worry is not, you're not able to solve 2 or 3 questions here or there. Please do not get discouraged. Stay firm on the ground and stay focused. COVID has impacted, the mental health of a lot of children, and the concentration has gone down. But there are certain, some students who are highly motivated to still work and build their careers. So please use this time, this COVID time, to prepare very hard. Take a break, go for cycling, do exercise or whatever you want to do. It's very useful because it gets very monotonous if you do over preparation. Do not do over preparation. Don't try to join 3 institutes, 5 teachers, and so on and so forth. Find what is best for you, and go with that. Trust is very important. So whichever place you trust, go with that. It doesn't matter. It's what people say about it. Go ahead and do what your gut feel tells you is good for you. But don't be shy of hard work. Please ensure that you also keep progress kind of report. But did you make any progress in last few months in physics or not, in your understanding? And don't allow the fatigue, which is very bad if you try to do over preparation. So my best wishes are with you, and my video on explanation of the combined motion, which is the rotational motion and translatory motion, will start now. Thank you very much. All right, so let's start with the concept of combined motion of which is translatory. So that's your translatory motion, okay, and a rotational motion. Okay, these two are being. So that's your rotational motion. So here is a rod, okay, and this rod has 2 types of motions. So one is, of course, it is moving straight, and if this only had translatory motion, it would have reached here. Okay. So this is your point A. Now assume we know the motion of point A, and this is point B, and then because of the translatory motion, they cover certain distance which is linear in nature. Now this is the translatory part of the motion. Now let's consider the rotational part of the motion. Now the point B. Now let's talk about the rotational motion. Okay. Now what happens is, so this is pure translatory motion. And then assume this body has both translatory and rotational motion. So that's your rod again. It can be any rigid body. And then this body, after some time is seen to be reaching here because of, so if you see the difference, the situation number 1 and the situation number 2, so this is your situation number 2. In the situation number 2, the body has both translatory and rotational motion. And if you just compare it, if this was pure translation, the body would have reached here, okay? So this would become identical to situation 1. So that's your situation 1, and this too is your pure translation. But what you see is that the body has traveled an extra distance, especially the point B. If you consider point B, this extra distance is because of rotation, okay? And the distance which it covers because of pure translation, which is this in some time interval, is identical here. So what you see is this distance is because of translation. So this is because of translation, and the extra distance is because of rotation. Okay. So the way you express this is, so this is still your point A, and this is still your point A, and we see that this is some extra. So this distance is extra. Okay. And this translation distance is identical to this distance. So the point number B, which is your point here, the point B, if you have to write what is the displacement of this point B, it is actually the sum of the translatory part, which is R translatory, and you can call it this or this, doesn't matter. So this is your R translatory. And B has also moved some extra distance, which we are showing like this. Now, how do you calculate this? In the question, like these, where you have combined translatory motion and rotational motion, this type of motion is also called as general motion. Now, our focus is point B. The way to find the extra distance is, or if you have to write the equation, is that, the extra. So I'm going to call it delta R, which is delta R, the extra distance traveled by the point B. Now what you do is, this is R translatory, which is actually, the translatory distance covered by A. So this distance or this distance is same as which is covered by, so we can write this as RB is equal to RA, which is pure translatory, plus the extra distance due to the rotation. Now, how do you look at the rotation is very important. The way to look at rotation is, is use, I told you, you have to use some relative motion. Keep a person here, and this person, is standing at A and looking at B. So make the other point as a fixed point, and the other point whose motion is being studied as a one which is rotating about this point. So, so the rotation is happening about A. So rotation is happening about A, right? Now, from your knowledge of circular motion, you might remember that if you have to find, if A is a fixed point and B is located at some distance, which is known, for example, the length of the rod, for example, this is known, then the point B, would cover some, angular distance, and the velocity of point B will be omega into r. So in these questions, if you look into the situation number 2, you will be given an omega of the rod or whatever you see. The second thing you will be given is the velocity of one point, which is, the velocity of A in this case, for example, and I'm just highlighting this. And therefore, when you take derivative of this equation and you write drb upon dt is equal to dra upon dt plus the derivative of extra distance, this is already delta, so just divided by delta t. What you get is the velocity of point B is given by VA plus omega r. And this omega r was calculated by using the concept that, keep A as a fixed point. Actually, they will give you the velocity of A, but for the calculation of this, what is the extra velocity which is attained by the point B, make A as fixed, use the omega which is given in the question, and go ahead and calculate this. So you will get the final velocity of B, which is another point on the rigid body. So this is your rigid body, which has both translatory motion and rotational motion. So you can expect some questions in NEET, JEE, and not sure if your school will ask these type of questions. These are a bit complicated. But the general motion, which is a combination of translatory motion and rotational motion, is a very important concept which has to be learned for NEET, JEE, or any other board. If you're preparing for Cambridge International Assessment, APE, or whatever board you're preparing, you still need to do this. Very important topic in the chapter of rotational motion, because it combines the concepts of translatory motion and rotational motion. The combined motion is called as general motion. So gentlemen and students, I hope you enjoyed this. And study rotational motion with a pinch of salt. It's a bit difficult, but the best way to study rotational motion is to continuously make a comparison with the linear motion, and say, okay, in linear motion this is velocity, and in angular motion or the the rotational motion, this will be called as angular velocity. So you can draw analogy also. For the time being, time to say goodbye to you. Good night. Thank you very much, and wait for my next video. I appreciate your time. Thanks.